Hello students, I am A.K. Dubedi. Welcome to part 10 of our chemical bonding series. Today we are going to discuss about or talk about chemical bonding and molecular structure with a special reference to hydrogen bonding. So we know that hydrogen bonding play a very important role in entire chemistry, especially in organic chemistry or in physical chemistry, as well as in inorganic chemistry. With the help of hydrogen bonding, we are able to explain the state of the molecule, melting point, boiling point, solubility, viscosity, surface tension, and different types of reasoning questions like why ice floats on water. So today I am going to explain one by one. First of all, I am going to define chemical bonding in terms of hydrogen bonding. Then differentiate between intermolecular and intramolecular hydrogen bonding and explain physical properties like boiling point, solubility, viscosity, density, anomaly of water using hydrogen bonding. Compare substance like water, ammonia, HF for strength of hydrogen bonding. Assess the importance of hydrogen bonding in biological system. This is very important. DNA and protein. This is also known as extracellular activities. How one subject attach with another, cross link connection. Nowadays in competitive examination, the questions are coming from different chapters. So one concept is used in another chapter, like hydrogen bonding is used in chemistry as well as in proteins, in DNA. Then predict the real life scenario where hydrogen bond play a role, that is ice floating on water, nylon strength, hydrogen bonding in drug molecule. So one by one I am going to explain. First of all, hydrogen bonding. What is hydrogen bonding? So very simple. The attractive force which bind hydrogen atom of one molecule with highly electronegative atom, basically FON. There are three elements, fluorine, oxygen and nitrogen are most electronegative, in which fluorine is the most electronegative, then oxygen and then nitrogen of another molecule is known as hydrogen bond. The strength of hydrogen bond is 10 to 40 kilojoule per mole, which is very less than the strength of covalent bond. Again one question is arise, what is the difference between hydrogen bond and covalent bond? Hydrogen bond basically depends upon the dipole-dipole interaction. The magnitude of dipole-dipole interaction is directly proportional to polarity. So polar plus polar, if two polar molecules are present, then dipole-dipole interaction takes place. And covalent bonding involves actual sharing of electrons. The strength of covalent bond is high, but the strength of hydrogen bond is very small, since no proper bond is formed. Hydrogen bond is represented by a dotted line. And the most important question is, what is the cause of hydrogen bond? Why hydrogen bond arise? So electronegativity difference, En difference, electronegativity of fluorine is 4 and hydrogen is 2.1. So in case of HF bonding, this bonded pair of electron is shifted towards fluorine because fluorine is the most electronegative element. So fluorine acquire a partial negative charge and hydrogen acquire a partial positive charge. Then HF molecule becomes dipolar. So hydrogen acquire a partial positive charge and electronegative element acquires a partial negative charge. The force of attraction between two ions, positive ion and negative ion, is basically known as hydrogen bond. Then conditions of hydrogen bond. Conditions. What are the conditions? Why, under what condition hydrogen bond is formed? So, highly electronegative elements should be attached to hydrogen atom, that is fluorine, fluorine, oxygen and nitrogen, and size is a small size of electronegative atom. Then in case of HF molecule, hydrogen and fluorine have covalent bond and oxygen have hydrogen bond with hydrogen. In second case, hydrogen bond of hydrogen with fluorine, with oxygen, with sulfur. So, hydrogen bond strength depends upon the electronegativity. Oxygen, in case of fluorine and oxygen, 40 kilojoule. In case of fluorine, hydrogen, fluorine, 20 to 25 kilojoule. So, this data depends upon the electronegativity. In nutshell, HF is able to form maximum hydrogen bond, then water and then ammonia. It is only because of hydrogen bonding. Then HF molecule, this is very important. HF molecule exists in zigzag form. HF molecule, this is the hydrogen bond, one molecule. Then HF hydrogen bond is due to polarity of H plus is positive and F minus is negative. The angle, zigzag angle, is 104 degree. And the most important part, covalent bond between hydrogen and fluorine is 100 picometer, but in hydrogen bond longer than covalent bond, and that is 155 picometer. So, HF molecule exists in zigzag manner. In case of electronegativity of fluorine, polar end leading to the strong intermolecular hydrogen bonding. So, HF molecule remains associated through H bonding even in gaseous state. In ammonia or in water, the difference on the basis of electronegativity. So, in case of water molecule is polar molecule, permanent dipole, because oxygen have two partial negative and hydrogen have partial positive. In case of ammonia, nitrogen have 3 partial negative charge, hydrogen have 1, 1 and 1. Each hydrogen attached with nitrogen. So, this type of bonding is known as intermolecular hydrogen bonding. Then types of hydrogen bond, there are two types of hydrogen bond. Number one is intermolecular hydrogen bonding. Intermolecular hydrogen bonding, in which hydrogen bonding is formed between two different molecules of the same or different substance. For example, between HF same molecule, HF and water different molecule, water and water same molecule. But in case of intramolecular hydrogen bonding is formed hydrogen atom and the highly electronegative atom, that is fluorine, oxygen, nitrogen, present in the same molecule. For example, orthonitrophenol, orthonitrobenzoic acid, orthohydroxybenzoic acid, that is salicylic acid. The next topic is conditions for hydrogen bonding. So, there are two more important conditions. Number one, the molecule should contain two groups, so that one group contains hydrogen atoms linked to highly electronegative element and other should contains highly electronegative element linked to less electronegative element. And number two is the molecule should be planar. Then number 3, I am going to explain with the help of example. Number 3, orthonitrophenol. Orthonitrophenol. Orthonitrophenol means phenol group, that is carbolic acid in OH, nitro group is attached with ortho position. So, in this case, due to chelation, this orthonitrophenol molecule forms hydrogen bonding, in which hydrogen is in between the most electronegative element, oxygen or hydrogen. This is OH bond, normal OH bond. In this case, cyclic compound formation, नाइट्रो ग्रुप लाइक दिस. सो यहाँ आपने देखा कि हाइड्रोजन एक्वायर पॉजिटिव चार्ज एंड ऑक्सीजन एक्वायर नेगेटिव. सो डॉटेड लाइन रिप्रेजेंट्स द बॉन्डिंग बिटवीन O and H. Molecule itself hydrogen bonding is known as intramolecular hydrogen bonding. Intramolecular hydrogen bonding. And this process of cyclization is known as chelation. So, due to chelation, orthonitrophenol is able to form intramolecular hydrogen bonding. But in same molecule, if nitro group attach with para position like this, NO2, this is orthonitrophenol in this case and nitro group in para position. So, paranitrophenol forms intermolecular hydrogen bonding because para position is more symmetrical. So, large number of molecules are associated in this case. Oxygen acquire partial negative, hydrogen acquire partial positive, hydrogen acquire partial positive, oxygen negative, and large number of molecules are associated. In intermolecular hydrogen bonding, this is known as intermolecular hydrogen bonding. So, in case of intermolecular hydrogen bonding, associations takes place. This is known as basically association. Due to association, large number of molecules are comes together and cause of association is increase in size, increase in size. So, due to association, size increases. If size increases, automatically molar mass of molecule, molar mass of molecule increases. And one very important question is arise, orthonitrophenol and paranitrophenol have same molecular mass, but due to intermolecular hydrogen bonding, large number of molecules are associated in paranitrophenol, but in orthonitrophenol, molecule itself a hydrogen bonding. So, how to separate orthonitrophenol from paranitrophenol? So, orthonitro and paranitrophenol are separated by steam distillation method. Orthonitrophenol is more volatile than paranitrophenol because mass of paranitrophenol is more than orthonitrophenol. That is why the melting point or boiling point in case of liquid state, paranitrophenol have higher boiling point than orthonitrophenol. Similarly, in case of salicylic acid, orthohydroxybenzoic acid, this is the formula of orthohydroxybenzoic acid, like benzoic acid is C and orthohydroxybenzoic acid. In this case, acid group is more powerful than hydroxy group. So, this is 1 and this is 2, second position is ortho. Again in this molecule, intramolecular hydrogen bonding is possible due to cyclization. In this case, C, OH and double bond O, in this case O and H. So, hydrogen acquire negative, oxygen acquire positive. So, due to chelation, this electronegative element oxygen and this electronegative element oxygen and intermediate is hydrogen. So, in intramolecular hydrogen bonding, hydrogen is attached with two electronegative elements and this bond is known as intramolecular hydrogen bonding. So, this molecule is also able to form intermolecular hydrogen bonding. So, this is the example of intermolecular and intramolecular. Then most important part is consequence. What are the consequence of intermolecular or intramolecular hydrogen bonding? Consequence of intermolecular hydrogen bonding. Intermolecular hydrogen bonding. So, this is very important for reasoning question. So, I am going to explain one by one. First of all, number one is association. First point is association. So, association play a very important role. We know that intermolecular hydrogen bonding, first of all association, and due to association size of molecule increases and molar mass also increases. When molar mass increases, van der Waals force of attraction also increases. Then point number 2, after association, the most important point is solubility. So, solubility increases. Why solubility increases? So, any substance which is able to form hydrogen bonding, any substance which is able to form hydrogen bond with water is soluble in water. So, solubility means molecule dissolved in water. So, we know that all organic compounds containing fluorine, oxygen and nitrogen are dissolved in water because they are able to form hydrogen bonding with water in intermolecular form. Number 3, physical state. This is very important. Physical state. A very simple example, H2O and H2S are hydrides of 16th group. H2O is liquid, but H2S is gas. Why? Due to hydrogen bonding. So, water is able to form hydrogen bonding due to high electronegativity difference, but H2S in bond between hydrogen and sulfur is less polar. So, this one is less electronegative. So, in this case the state of water is liquid, but H2S is gas. Number fourth point is melting point and boiling point, MP and BP. This is very important. I am going to explain by taking an example of hydroacids. For example, ammonia, phosphine, arsine, antimonine and bismuthine are hydrides of 15th group. These are the hydrides of group 15th in the periodic table. So, on the basis of molar mass, we know that molar mass increases down the group. When molar mass increases, van der Waals force of attraction increases. So, melting point increases. In this case, melting point of ammonia is lowest and bismuthine is highest, but due to hydrogen bonding, the melting point of ammonia NH3, the melting point of NH3 is 195 Kelvin, and bisphosphine is least, that is 138 Kelvin due to lack of hydrogen bonding, and arsine, antimonine and bismuthine, molar mass increases from phosphine to bismuthine, so melting point increases. So, on the basis of graphical representation, we are able to explain the melting point of hydrides of 15th group. In rough manner, ammonia is highest due to hydrogen bonding, phosphine is lowest, and then again mass increases and boiling point increases. So, this is ammonia highest, phosphine is lowest, arsine, antimonine and bismuthine. This is again possible in case of water molecule. So, hydrogen bonding play a very important role to explain melting and boiling point. Next is influence of physical state, why water is liquid and H2S is gas due to hydrogen bonding, and most important part, on the basis of mass. If mass increases, molecule becomes less volatile. So, the next point number 5 is volatility. Volatility is inversely proportional to hydrogen bonding. Means extent of hydrogen bonding increases, volatility also decreases. Hydrogen bonding is more, molecule is less volatile. Next point is viscosity and surface tension. Viscosity and surface tension. For example, like ethyl alcohol. Ethyl alcohol or ethanol have one OH bond. Glycol, they contain 2 OH, and glycerol contain 3 OH. So, in this case, on the basis of very simple observation, H bond, hydrogen bonding or extent of hydrogen bonding increases from alcohol to glycerol. That is why viscosity. Viscosity increases. Viscosity increases. So we know that glycerol is used in shaving creams. Due to presence of shaving cream, glycerol present in shaving cream becomes more viscous. So glycerol is more viscous than ethyl alcohol due to extensive hydrogen bonding. So surface tension of water is more only due to hydrogen bonding. Then one question is arise, why ice floats on the surface of water? This is the application of hydrogen bonding. Why ice floats on the surface of water? So application of hydrogen bonding. Application of hydrogen bonding. So we know that ice floats on the surface of water because during the formation of ice, hydrogen bonds are created, and we know that in case of water molecule have permanent dipole moment. So one molecule of water is able to form one molecule of water attached with 4 different molecule of water tetrahedrally, and again they form hydrogen bond. So covalent bond length in water is 99 picometer, but OH, that is hydrogen bond, is 177 picometer. So due to formation of new hydrogen bond in ice molecule, they form cage like a structure and they are attached tetrahedrally. When the number of hydrogen bonds increases, volume of ice increases, and we know that density equals to mass upon volume. So when volume increases, density decreases. That is why water have more density than ice and ice have less density than water. So ice floats on water. Each oxygen atom forms 4 bonds, out of which 2 are normal covalent bond and 2 are hydrogen bonds. So hydrogen bond is longer than normal covalent bond. Due to this open cage like a structure, volume becomes more and density becomes less. Then second question is, water has maximum density. Water has maximum density at 4 degrees Celsius. When ice melts, there is a rupture of open cage like a structure due to partial breaking of hydrogen bond. This makes water molecule to come closer and fill the vacant space, causing decrease in volume and increase in density, and ultimately complete structure collapse at 4 degree Celsius. That is why water has maximum density at 400 degrees Celsius. Then I am going to explain what is the cause of hydrogen bonding. For example, a very simple example, that is acetic acid. Acetic acid molecule is able to form dimer due to hydrogen bonding. So in acetic acid, CH3C double bond O and OH. Second molecule combines like this and 2 molecule comes closer, in which hydrogen acquire partial positive, oxygen acquire partial negative and partial positive. And due to formation of dimer is due to hydrogen bonding. So in dimer formation, the value of n equals to 2 means actual number of molecule exist in acetic acid is 2 moles. So, mass of acetic acid becomes double and Van't Hoff factor becomes 0.25. It means in case of acetic acid association takes place, and due to association the boiling point of acid is more than alcohol, respective, because both are able to form hydrogen bonding. So, ethyl alcohol, acetic acid, amide, primary amine, secondary amine, lower member of aldehydes, or all are able to form hydrogen bonding. So, in case of organic molecules, especially in case of alcohol, aldehyde, carboxylic acid and amines, lower member are able to form hydrogen bonding, intermolecular hydrogen bonding. So, they are soluble in water. If molecule itself have hydrogen bonding, so this point explain the boiling point. If molecule forms intermolecular hydrogen bonding with water, the point explain solubility in water. So, please learn the entire part of this video. This is very important for your competitive examination as well as in CBSE examination. Thanks for watching.